Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro.
Good morning, everybody. I'm Pabzh, Creative Tech here at Adafruit. Every week, we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is a show we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Welcome back to the show. Episode 438. It is May 1st, 2024. Hello, everybody. We're hanging out in the Adafruit Discord. If you'd like to join us throughout the show, you can say hello on the live broadcast chat channel on the Adafruit Discord server. The URL to go there is discord.gg/Adafruit. Hello, everybody. We're back. We were out last week. We took a small break for spring, as spring has sprung here in our part of the world. And we just want to welcome everyone back. We are fully refreshed. We have a new project. We have a new project that we're prototyping, Time-lapse Tuesday, and a community make. Yeah, Pedro, shout out everybody who's watching in while I sip on some coffee.
Yeah, if you guys want to join in to get some shout outs, go on over to the Discord over at discord.gg/Adafruit. Also on the YouTube, LinkedIn, Facebook. Is this where else am I?
X,
yes, that's the one. Giving shout outs to everybody hanging out in some of the chat rooms. Sue Wester, Jim Hendrickson.
Hello.
Good morning.
Yeah. Sweet. We had a good break and we are ready to drop some new projects.
Yay.
But first, let's kick it off with the deals going on this week while supplies are lasting here. If your order is $99 or more, you're going to get a free PCB coaster with a golden Adafruit logo. This gets automatically added to your cart at checkout. No need for extra coupon codes, but you can apply a coupon code, which we'll have a little bit after the segment. If your order is $149 or more, you'll get the PCB coaster plus an Adafruit KB2040 featuring that RP2040 chip from the Raspberry Pi. If your order is $199 or more, you'll get the Adafruit KB2040, the PCB coaster, and free UPS ground shipping for continental US only. If your order is $299 or more, you get the free ground shipping, the KB2040, the PCB coaster, and a Circuit Playground Express. These get automatically added to your cart. And if you want to apply a coupon code, you can use a memory gun at checkout and get 10% off your total order. This coupon code is good for the next 24 hours. It expires tomorrow. So check it out. And we'll reference back to it in the later segments. Hello, Tyeth, hanging out. We got Jim Hendrickson and Dew Wester saying hello in the Discord server. Thank you for joining us.
Morning.
Coffee's too hot. Gotta let it cool down.
Either too hot or too cold.
Oh yeah, it's hard to find it in just the right spot where it's like delicious. All right, so this week we released the memory gun inspired from the memory gun from Gravity Falls. This is a very fun Feather PropMaker RP2040 project. Pedro, you built two of them. I have mine here. It's a really fun, unique design of a prop. It lights up. It has a trigger button. It makes sounds. It's got an LED Noodle. You got a thumbs up there. Very nice. One of the cool things I liked about this prop is that it has a built-in screen. In the show, they use the screen to kind of display some text. The point of the prop is to capture and erase memories, and the memories are stored in like these little canister things. And then you can use this dial to kind of dial in the text to record the memory. But in our case, we figured let's use the Rotary encoder to cycle through a list of sound effects. So the OLED has it displays 3 different text elements, and the center element is highlighted, letting you know that's the sound effect. So the code is done in CircuitPython. Big shout out to Liz Clark for collaborating with us to create the code for this one. And excuse me, it uses the Adafruit PropMaker Feather because it has the built-in amplifier, 3-block terminals, Stemma QT, all of the features that you need for making a good portable prop. It's got built-in LiPo charging, and you have access to the USB-C port for programming and charging the battery. The battery is hidden inside the handle. The trigger button is just a regular push button. The rotary encoder is Stemma QT. That's daisy chained into the OLED Stemma QT. It's a 1.3-inch OLED. It's a monochrome, so it's just one color, but it looks really cool. And then for the LED, it's the LED Noodle. It can be a number of different colors that you can purchase, but this one's blue, and it shows it blue. This is a plastic ornament that you can purchase off of Amazon. You can get a pack of 12 of them for relatively low cost. So instead of 3D printing the bulb, I figured just purchase a off-the-shelf Christmas ornament, and it worked out really well. So that's pretty much the prop. The features, the speaker is hidden in here inside of the casing for the breakout, the OLED breakout. And it sounds pretty good. It's got some good volume to it. Some extra details that make it kind of cool is this piece of acrylic. You can, of course, 3D print this, but I figured I'd use some of this cool fluorescent pink filament or acrylic, but you could 3D print it, of course. But nothing like a piece of acrylic that has a super smooth glass-like finish. So yeah, that is the prop. It was a recommendation from Kiddo, Pedro's kid Gavin, my nephew. He is a fan of the Gravity Falls TV show, and he recently got Journal 3, I think, for Christmas. So he's been loving that book. And a part of the book, there was the memory gun, which he said, hey, why don't you guys build that? Can you guys build that? And I took a look at it, and I was like, that is pretty cool. It's a unique blend of components. I really like the light bulb and the rotary encoder. And I haven't really done a prop yet with an OLED display, so I figured let's give that a try. So that's the project in a nutshell. Pedro, I can't hear you. Are you muted?
Sorry. I cut to the camera. I think it takes off my audio as well.
Oh, you have to show them all at the same time.
I know. I didn't want to, though. Just one of them. It's like you're just looking at my face. I'm not doing anything. Interesting stuff is down here. But I was saying the filament, the noodle, the LED noodle is a super cool way to incorporate that into the lighting effect.
Yeah. Yep. What else can I say about it? I don't know. What do people say about it? This is Discord says hello. Okay. All right. So our Learn Guide covers the assembly, the code, the CAD files, everything you need to build your own. We have a couple parts here that are listed. You're going to need the PropMaker Feather RP2040, the LED Noodle, the 1.3-inch OLED display, the rotary encoders with Stemma QT, mini oval speaker, and a handful of other little components like the button, the slide switch. The battery is a pretty nice battery. It's that cylindrical battery. It's got 2,200 milliamps of capacity. I think it'll run for like maybe 8 hours plus, depending on how much you use it. But it is rechargeable via USB on the Feather port. You're going to need some Stemma QT cables, at least 2 of them. Plastic bulb you can get from Amazon. You'll need a resistor for the OLED, or not the OLED. You'll need a resistor for the LED Noodle. And then some wires. I like color-coded wires, so we figured we'd use them here. And it helps with the assembly, too. So a handful of hardware. It's actually 16 M25 screws, some longer M3 screws, and some hex nuts, but the list is there for you. On to the circuit diagram. It looks like there's a lot of connections, but Stemma QT makes it really easy to connect those two components, the OLED and the rotary encoder. Without Stemma QT, you'd be looking at a lot of wired connections, but these are just daisy chain, making it so much easier. And they're done through I2C. That's what Stemma QT does. And then the screw block terminals, most of the components get just wired into that, which makes assembling so much easier. You don't have to solder things and thread things through. It's easy to disconnect it. And I've taken this thing apart so many times, especially when I was documenting the photo assembly. And those screw block terminals are just the best thing. There are some things you want to solder to the pins on the Feather. That's just the slide switch. 2 wired connections, not a big deal. So those are laid out here. These circuit diagrams are created with the Fritzing software that's open source. I think it's paid now, but it's a great software for creating these lovely visual diagrams for circuits. And we continue to use them, and our parts, our Adafruit parts for Fritzing are still being developed, and we have those available for folks to download. You can just kind of grab those from the GitHub repository if you'd like. Moving on to CircuitPython, we recommend installing the latest version of CircuitPython to your Feather RP2040. Really easy to do so. You get it in the bootloader mode, you drag and drop the latest version, and it installs auto-magically. Again, shout out to Liz Clark. She is our #1 collaborator for all of our prop projects, and she continues to make some really cool code for all of our props. It's all commented here. You can download the code, the libraries, and the sound effects using this button, Download Project Bundle. It'll get everything for you, so you can just drag and drop them onto your Feather's USB drive. You can add as many WAV files as you like, as long as it fits on the storage. I forget what the max storage capacity is, but it's good enough for a handful of sound effects. I've included 10, but I'm sure you could probably double that because they're really short WAV files. So they're all nested in a waves folder, and you'll want to just make sure that the waves are a certain bit rate. I think 22.5 kilohertz is right. The bit rate. Sounds about right? And then we have a guide too on like how to convert your audio files to CircuitPython. You can check that out. We are using a font, a custom font for the OLED display. You can create your own custom fonts. It's a bitmap font, or you could use the built-in font as well, whichever font you want. But we supply it rather in the project bundle, so you can grab that. This just shows you how to set up the text elements on the OLED display, and the rest of the code kind of just tells you if you're pressing the button, play the sound effect. If not, don't light up the thing. Pretty straightforward. I think it's a good use of the OLED display and a rotary encoder for switching through a cycle of list items or audio files in this case. So we got a nice code breakdown here, a screenshot of what the CircuitPy drive looks like with all your libraries and sound effects. I think I didn't mention, but the OLED will look at the audio files, and whatever you have that audio file named, like the file name, it'll just display that on the OLED display. So if you want to have a list of names of a person speaking or something, if you're doing something different, you can have it display a person's name. Excuse me. I think we were going to originally do that, but I just ended up naming the sound effects like what they sound like to me in my head. So that's why they're kind of these interesting, like electronic boom and pulse wave and signal drop, static fizz. These sound effects were created with a sound pack that's royal free, and I just kind of combined a couple of them together to make these kind of blaster type sound effects. We've been kind of rehashing these a little bit in like the Loki TV baton and some of the other I think the Zelda swords and stuff. They have kind of similar kind of sounds, but I like the sound pack. It's from Motion Pulse from Video Copilot, which Andrew Kramer, he's an amazing person in the community of visual effects, and he created this thing like a couple decades ago now, but they're just super good, like fun sound effects. Any manner, you can change it up and learn a little bit more about CircuitPython by just reading through the code breakdown. Onto the CAD files. There's quite a few parts because I don't know what the total count is, maybe like 24 parts. Mainly because like there's just different colored parts. Nothing needs supports, so it's easy to FDM 3D print them. and all the standoffs are kind of built in. You just need hardware. Nothing really needs glue, other than like some of the details. There's decals, like the handle grips. Although you could use vinyl. That's what I did with mine. I could talk about it a little bit later, but I used vinyl cutter, a little Cricut vinyl cutter, and some transfer tape to because it has like an adhesive. And I found this nice textured vinyl. But in any manner, you'll need a 3D printer with a build volume of 150 by 150 by 80. That's kind of the biggest part. So that's kind of there. I have some suggestions for at least these two parts. They're kind of thin, and I recommend using a brim when you're printing them. So that's listed there. You'll want a handful of translucent filaments, particularly for the LED noodle holder. That's printed in a clear, translucent PLA filament. And if you want to 3D print the shield blaster, you'll want to choose like a reddish or a pink PLA that's translucent. So that's what we got. And then I actually listed here, I normally don't do this, but I had really good results with the Polymaker's Gold PLA Pro and Protopas's Metallic Brown PLA. This stuff is a really good high quality filament. It's not brittle like some of the silk filaments. Like it's got a good kind of layer adhesion, and they're not brittle. So I really recommend these. So that's why I have them listed here. Pedro, I think you used something different for the gold.
I used the Hatchbox Gold, and I used a combination of both the Protopasta Metallic Brown and copper from who was it? Stronghold, I think.
Stronghold. Okay. Yeah, all good brands. I try to stay away from the silky stuff when it comes to props because I found them to be brittle.
Oh yeah.
About the formula.
Surprisingly, though, when we talk about the prototyping section, this prototype was printed in silky metallic gray, silver, and it came out really good.
And
I specifically used it because I'm like, let me use up this trash filament.
Oh, that's funny.
Lo and behold, it came out amazing.
That's great.
So
all right, not every filament brand is created equal. But
this one's from everyone though, so it isn't like the cheapo one. Well, it is cheap, but not like dirt cheap.
Okay.
No brand.
Yeah. I included some SVG files. These are the vector files for laser cutting or vinyl cutting, the handle grips, and the blaster shields. So if folks have access to like a laser cutter, you can use the SVGs to cut out the grips or the shields out of acrylic or whatever other material.
PETG is what I used.
You use PETG?
Yeah. I think if you
that looks very clear.
If you use the XTC, maybe if you use that, even more, because it doesn't get transparent until you're pretty close to it. Otherwise it's like, it's like super frosted.
Yeah,
look close.
Cool. Yeah, it's pretty close. Yeah. Okay, so all those files are available. There's a step file and a Fusion 360 file if folks want to modify the design. I know folks like that. And then if you want a 3D model of the Stemma QT rotary encoder, the OLED breakout, or the Feather PropMaker RP2040, we have 3D models of them in our CAD parts GitHub repo. So grab those, and also available in different file formats. All right, on to the wiring. This covers wiring up the LED Noodle. You want a resistor. I got a 100 ohm resistor here because it's a blue LED, and we want it to be fairly bright.
Yes.
You can use different colored silicone coated wires. I got a red and a black one to indicate the anode and the cathode. The push button, same thing, just wired up, but no resistor. I have wire lengths there, which is really nice. You never want a wire that's too short or too long, so that's why we tend to add wire lengths, but it's pretty straightforward. You solder up 2 wires to each terminal. Slide switch gets some short wires. Doesn't matter what color they are, but they do get soldered to the bottom of the Feather. And then the speaker, you could add if you don't want to cut the connector off the included connector port on the battery, you can use one of those extension cables for the Pico Blade connectors. That's what you did. Yeah, I would have done it too, but I don't have them and they're out of stock. So the easiest thing to do is just to cut it off.
Yeah.
Use some wire strippers and tin the leads.
Save the end just in case.
I did. Yeah, I saved the end because yeah, because we do have some boards that have the Pico Blade connector, like the male end or the female end. I guess the socket end and the plug end, and it's easy to plug them in. But in this case, we're using the PropMaker Feather screw block terminals, so you're going to want to have some wires that are exposed like that. So that's setting up the main components there, and that's really all the wiring you need to do.
Yeah, you're gonna have to do that because I think we are out of the little speakers, the short ones we have in stock are the longer ones, so I stocked up on those.
Yeah, and then you might notice where's the wiring for the OLED or the rotary encoder. Those are ready to go. You use cables for those, and we now have pre-soldered rotary encoders. So you have the option to get them pre-soldered.
Saved my butt. I thought it was kind of silly that they're,
these guys.
But the first one I soldered, the way I'm was getting shots or something, it came out like crooked.
Oh, that's fun.
Yeah. So when you're rotating the knob, not this one, I threw it away. I picked up one of the soldered ones. So I was like,
okay.
Well, the kids immediately noticed. They're like, Daddy, can you fix this? Because look at the rotary. It's like all wobbly when you rotate it.
Yeah.
I just didn't push it down all the way, or maybe when I soldered the pins, it like popped off from the heat or something, but it was just not level.
Yeah.
So I would
it's great to have these pre-soldered. Yeah. Not only you're going to get a good solder connection, but you don't have to worry about it.
Yeah, I mean, now I see it as a waste of time to sit there and solder that, because it's like, well, what other rotary encoder are you gonna get?
Yeah, that's true. Because like wiring up a bare one, we've done it before, and it's just many wired connections.
That's why I started off with that one, because that's what we're used to. But then I did it wrong. Actually, no, that's not the first time where it's kind of came in all crooked.
Yeah.
And then just just soldering it up, with the little hands, the way we
holding it in place is the thing. You want to use tack, but then the tack can get melted. So
I got plenty of other stuff to solder. Skip this one. So yeah, I would definitely go with the pre-soldered one.
Absolutely. All right. Once we're done wiring up our components, we can start assembling. The 2200 milliamp LiPo battery gets fitted inside one of the halves with the little clips that are built in for it. That just kind of holds it in place. It should have kind of a loose fit, but I don't want it flying around. So I figured instead of having like a super tight grip, and all the batteries have slightly different diameters, so this just makes it so it just doesn't completely fly inside the handle. The button also gets fitted in there with a hex nut. You can just kind of screw it on and tighten it until it hugs onto the lip of that of the trigger.
There's just enough room to use the quick connects for the push button. You gotta see how I have mine. It is pushed out a little bit. That's not.
That's fun.
Oh, over here, the other camera.
Sure.
I'll actually focus. You can see how it is pushed out just. But that's just to have the quick connects fit in there, but it does work. It does fit. You will lose spacing between your finger and where the button is.
Right.
These is for the kids who have little fingers anyway. So
true. Okay.
Makes it easier for them to trigger.
Yeah, you have options if you really don't want to solder, and you have those quick connects on hand. There's room in there.
Yep, you just need an extra washer. 2 of those. I think it comes with two washers.
Oh yeah.
Sort of.
Yeah, it does.
Create the wall that you'll need to have it stay in place.
Yeah. All right. Once you get those in there, the other half just fits on top, and there's a little slot, a little hole for the battery connector and the button wires to come out. You'll want these 10 millimeter long screws to attach. They're just 3 screws. They keep it nicely secured. I just didn't want to do the snap fits for this irregular kind of shape.
It does not, no.
It kind
works, but it loosens over time. And
right. Yeah, and I want it to be secure.
Yeah.
When you're thinking about designing a prop that's kind of like fixed and it's not going to be taken apart, go for screws. If you do need to change the battery out, you can just unscrew it.
Yeah, you can feel the difference.
Yeah,
between something that's screwed and something that's.
I've done props before with the snap fit things where you put a lot of use into it. You're holding it a lot. You're dropping it, and it tends to like fall apart. So. Yeah. Not the snaps aren't great. It's just like
I mean, we use
the application. You
used it for the
need to be sturdy. I did.
You've been holding the weight of.
Exactly. Yeah, and you're not holding on to that a lot. So.
Yeah, exactly. This is like one. Like a gram.
It's a good design consideration, I think. And anyway, they sink in, so they're nice. They're out of the way, and most props with a sort of a ray gun, they have screws anyway, and the design actually does have screws in it. So it's like, okay, that makes sense.
Yep.
So it does double duty there. It's better assembly, and it actually looks like the prop. The OLED screen has its own cover. You just want to orient the board with it. These standoffs are kind of trimmed a little bit to accommodate for the OLED screen. Of course, be careful.
Remove the protection that is on the screen. Otherwise, it will get in the way. I cracked one of mine, like the glass part. The rest of the screen is fine, but the corner,
that's crazy.
When you do the cutaway, it's all because I didn't take off the little protection film.
Yeah.
Do that first.
Yeah, definitely take that off first.
Mm-hmm.
And anyway, they get these small screws that attach to the built-in standoffs, and I recommend machine screws, steel, metal screws, not nylon, because they just won't bite into the plastic you need it to.
Yeah, the nylon screws the threading will melt.
Exactly. Yeah, they'll strip right instantly. Anyway, the next thing to do is to set up the rotary case with the OLED case. Those get fashioned together with some additional screws here. So we covered that. And then you'll want to start setting up the PCB mount. There's like these 4 pieces that get sandwiched together to kind of make it look like how it does.
Mm-hmm.
So we start off with what's up?
It's like a riser because of the cylindrical shape.
Exactly. Yeah. So you had to kind of create these like coupler standoff pieces to lift the PCB mount away from the curvature of the canister thing. So anyway, we set these up. We kind of sandwich these things together, and then we attach it to the side of the OLED case. And there's a nice large hole in the center of those 2 mounting holes that allows the wires to pass through, because basically all of the wire connections are going to pass through this center hole. Mm-hmm. So once we get that set up, we're going to use hex nuts to secure it down, so everything's nice and tight.
I had to use 25 millimeter long screws.
Yeah, you barely just have enough threads for, if you look in the photo, but you can get away with it with 20 millimeter. I would recommend something longer. 25. Yeah, 25 is probably way better. And it's not gonna, it's not gonna get in the way of the wires. But yeah, if you have longer, use them. Yeah. It's just that I didn't have any on hand.
I only had them because you ordered them for, I think, one of the parts.
Yeah.
That one, it's either the 25 or the 30.
Yeah. You can get away with it. Like I said, I used some needle.
No, I started with the 20, and then as I'm assembling stuff, like the threading or the hole around it got too loose where it was just rocking. I'm like,
yeah,
longer screws.
Yep. Okay. Longer screws are better in this case. And anyway, you get that set up, and then we start doing the LED Noodle that gets press fitted into the into the 3D printed holder. So just kind of try to figure out where you take the length of the noodle and then like fold it in half so it's like equal, and then you just kind of fit it in through the little built-in channel of the LED holder. Once that's set up, you can fit it inside the plastic bulb, so that just fits in there. There's some like little curved lips that will keep it from like just falling and flopping around inside there, so it actually has a pretty good fit. And then we get the shield is installed next, and then the coupler, which has a mating thread that are designed to match the thread of this ornament. So that works out really well by just screwing it in. But in that case, you have your kind of sub-assembly of the LED bulb thing. And then we set that aside to start installing the speaker. I love these speakers because they have adhesives built into them on both sides. I recommend using the side that has the kind of fabric mesh. Just press that, line it up with the slot on the OLED case, and it just kind of stays in place from that. I find that to be the easiest than to do the snap fit thing. I've done snap fit before for that, but the tolerances are always kind of different, especially with something that's like angled. It's weird.
Yeah, the orientation definitely changes.
So I'll just like stick it.
Yep. I would push that kind of far into the speaker so that the little wires don't interfere with the OLED when you pop that in.
That's a good point. Yeah.
Push it in, or you have the wire long enough, I would turn that around so the wire's facing the other way.
Yeah. Either way, it works out. There's just enough slack for the cable to screw into the feather. But either way,
when you're first testing it out, just gently push it in there in case readjust the speaker.
You get about 2 tries with the stickiness.
The third, the stickiness will rip off the fabric and like tear apart the speaker. So
I've done that too.
Lightly push it to make sure everything fits first.
Yeah. But either way, I like the adhesive method. It just makes installing a speaker easy. Yeah. But anyway, once we got that inside the case, we insert that the speaker cable through the hole going out of the hole on the PCB mount. We're going to attach the, I guess we'll get the wires for the LED and kind of thread that through the 2 parts, and then kind of do the same thing where we thread it through the hole in the PCB mount. Once that's set up, we'll get the Stemma QT cable installed on the rotary encoder. We'll kind of thread that through the various holes and get it to feed out. And then we secure the rotary encoder breakout to the built-in standoffs on that on the rotary case. So that works out nice. You'll notice I only use 2 screws now. I'm trying to save on screws. You don't really need 4 screws, right? That's what you did. I was like, I'm gonna start doing that because I don't want to use up all my screws. And it's plenty secure. You're not pulling on it or anything, so it works out right. All right. After that, we're gonna get the cables from the handle. That's the battery and the button. You'll get those through the hole on the bottom side of the OLED case. Get those through. Line up these mounting tabs. And then we'll secure the handle to the OLED case using some additional screws. These are M25 by 6 millimeter long screws. And those just a really nice way to get it attached. And then from there, we'll get the button cables and the battery cables threaded through the hole. You're starting to get a lot of cables here. And then the OLED Stemma QT cable gets connected. This gets daisy chained to the Stemma QT cable from the rotary encoder. So that passes in through the OLED, and then the OLED has another Stemma QT cable that will get attached to the feather. So we're going to get that one threaded through the hole of the PCB mount, and then we can line it up with the case, the OLED case, and then snap it fit. This is where snap fit makes sense. I didn't want any screws exposed, and there's not a lot of weight or force being applied to this part. So it worked out really well. And you can always kind of use the spudger tool to pop it open if you need to, which works out really nice.
They're pretty hefty snaps too. That thing ain't going nowhere.
Yeah, it's got a nice tight fit. The tolerances are like 0.1 millimeters.
Yeah, it's super tight.
It's super tight, but not too tight, and that's good. It's a good balance. So after that, now let's get our feather switch. The little slide switch gets press fitted down. You could probably add a piece of glue if you don't want it to move around, or you can press open the tabs. You kind of pull them apart so that it has like a nice tight fit to it in between the standoffs. And then we'll start connecting the various components of the battery, the Stemma QT from the OLED, and then the speaker, the button, the LED goes to the 5-volt screw block terminal. You share the ground wires from the button and the LED. So there's one ground screw block terminal. So those got the 2 wires. And that's pretty much all the connections there. The feather is secured to the PCB mount. It only has 2 mounting holes on the standoffs. So just use some 2 M25 screws to secure that down. And from there, it's almost all done. The canister has a little cover that snap fits as well. I figured that'd be the easiest way to kind of join these 2 canister bits together. I think this worked out really well because splitting it in half made it so much easier to access the feather and being able to install and screw all the wires down to the screw block terminals. Otherwise, it would have been this weird way to fit it in, and then how do you secure it if it was a fully secured canister? So this ended up working well. These little snaps here for the 2 halves, and then this canister stopper. This is a little bit over. I would have glued these down.
But... I didn't know that hole was for a screw. I used that hole to stick some filament in there to align it for the glue, so that the piece would align perfectly.
Yeah, that's a good
kept it
idea.
aligned.
Yeah. Yeah, I'm just so anti-glue. I didn't. But if you want to glue it and save a screw, go ahead.
Thanks. Gotta leave the room every time I use it.
Yeah. But anyway, that's how I got that set up.
That's what I would have done.
Nothing special here. Just has a press fit. There's no snaps there, so you can easily take it apart. But it has a good hold. I noticed. Like it's got a good hold. It's got a good depth too. So like it has maybe like a 5 millimeter or 6 millimeter depth.
Push it way in there.
That pushes way down, yeah. So that way it doesn't pop off easily. And then this one has a similar thing where it's just like a lip, and the tolerance is going to fit out nice. You just want to orient the USB hole with the slide switch hole, and they should line up pretty good if everything goes together. The rotary encoder cover does have one of those stopper nubs things to snap fit. You just want to line those up with the nubs that are inside of the rotary encoder, and that just kind of press fits and clicks into place. And then the rotary knob has a nice tight fit too. It's got like a D-shaped shaft, so you just line up that flat surface with the flat edge of the knob, press fit it in, and it has just enough room for it to kind of freely spin and rotate. Yeah. Although the rotary encoder does have like a press switch, like a button, we're not really using it in this project. We were originally going to use that to select the sound effect. We figured, it's just better if you just, whatever is selected just plays. That way that you don't need like this extra piece of code.
Yeah.
Or layer. So it just feels more intuitive that way. What else do we do? We turn it on. We press the button. We use the rotary encoder. And that's the prop in a nutshell. Yeah, that's the whole assembly. Really happy with how it turned out.
Very good.
Super unique looking prop. Don't see many Gravity Falls props being made, so it was a good kind of fit.
It's ready when the new season comes out, if it comes out.
I heard they're done.
Oh.
Yeah, I heard they're done. The showrunner was like, no, it just needed to be that one thing.
So I guess it's just the book. That's what I'm thinking of.
Yeah, the books. Get the books. So that's the project. If you're a fan of Gravity Falls, I hope you enjoy it. And if not,
really good show.
I hope it inspires you to integrate displays, rotary encoders, LED noodles, and just Circuit Python. Like it really makes this thing kind of adjustable and easy to put together.
Yeah, I had to, do something in Arduino. I'm like, oh, I have to download all these libraries now.
Yeah, your board package.
Go search for this thing. Oh, I already had them. I just need to update it. Oh, this still isn't working.
Oh no. We have plenty of feathers in stock, so pick those up. You can use the coupon code Memory Gun. You get 10% off your order. But yeah, PropMaker, we got those in stock. There's still a lot of prop ideas that I want to do that to just use like half of the features. I still want to use a servo somehow for prop, the accelerometer, right? Somehow for the prop. But the majority of the things, like just controlling an LED with a button and having sound effects, that just goes a long way. And at least with this one, we're using some I2C, the Stemma QT components, like the rotary encoder and the OLED display. So that's cool. Keep trying to add like, these little features incrementally, like polish and add more features to our prop projects. So I hope it's inspirational.
Yay.
So check it out. So many cool props. Let's take a quick look at all the props that we've done. The magic wand was cool because it actually uses the servo. You got the lightsaber, the talking D20, the Adabot, talking Adabot. How about an instrument? We got an instrument. We did the HAL. We did Freddy, Five Nights at Freddy wrench that uses not an OLED, but like a LCD character display. John did a cool synthesizer glove, and now the newest props to the family, the Gravity Falls memory gun. So
that's all for the RP2040?
That's all that came up for the when you click on what guide this uses. This is it. The Master Sword. And that, I think, segues into, well, what's the next prop that is just dying to get redone?
It's going to be all of them.
It is going to be all of them. What is the
It's
next
gonna
one
be
you're
all-
working on?
Next one is going to be this Halo remake. So again, with the PropMaker RP2040, we're going to have sound effects, no glue. Everything will be screwed together. That was one of the biggest complaints, the way it was attached to the top here. So I got the updated version. I had to clean it up. It was literally one of the handful of first projects that were started modeling inside of Fusion 360. So inside of Fusion, this was used. What did we use? The modeling or sculpting environment.
Yeah, I think so. The
to
handle's
this nice
sculpted.
smooth handle. Adding like webbings to the standoffs. There's standoffs there just to hold the battery, and then the speaker go on the side. USB charging, of course, USB-C, and a little slide switch on there. So that's
nice.
as you were saying, the incremental updates to the props, to all the props, adding all the standoffs for the screws, so everything will be able to be disassembled. No more hot glue for all this.
Yeah.
No more aligning sticks. Remember using like skinny sticks to align things. Just use the screws for that. And what else? As you were saying earlier, I guess the printer, maybe the printer did it better. It's the Smart Pro is what I used, and I think all the silk stuff that I was using before was like some of the Bowden printers. So don't have any more Bowdens. So maybe that's what the difference is. Why you can't do it. But yeah, here is prototype. I think we'll have this for next week or the week after. Getting all of the standoffs all nicely aligned, and yeah, this will be part of the mounting part blade that attaches the rest of the assembly.
Cool.
And that'll be.
How did you print that with supports? I think.
Yeah, print straight up like that, and there's supports on the bottom here. I was gonna try tree supports again. It didn't work. I'm just using the standard regular supports. But yeah.
Cool. Yeah, it looks really good from the camera. I don't see any layer lines.
Oh, they're there.
Oh, they're there. Yeah.
I think I printed it at like 0.25 just to get the make sure that the standoffs were aligned properly. And the speaker has enough wiggle room in there, and I think it's the 2500 milliamp hour battery.
Oh, really?
Go right on the bottom of there.
Yeah.
We'll have sound effects, motion this time. The first iteration of it, we were using the 58. No, oh my god, I forgot the name.
What? I have it here. I have the Learn Guide.
There it is.
This is the old Learn Guide that uses the.
Oh my god, it's the 32U4. So I thought it was the 52 or the. Oh my god.
Yeah, I'm sorry. This isn't a trinket. It's a blue fruit feather. Yeah, but it's an old 32.
It's so old. Yeah.
NeoPixels, of course. Are you going to use different density?
No, I think I'm going to use the. Oh, actually, it's medium, the one that I'm using. I think that's the low density one. So yeah.
Yeah, 60 or 144. You used here a 2000 milliamp battery.
Yep, I'll probably use the same.
Yeah, these photos are still fantastic.
Yeah, I'll try to do more long exposure ones.
Yeah, so this one, it was
when
they first released, it was cool to do kind of a Bluetooth and change the color, but practically that doesn't make too much sense with this prop. It's always going to be blue, and you kind of want more of a motion activated effect. So the prop maker just makes so much sense for this.
Yeah. Even with the color changing, they could be like a motion, so it could be like point down, and
you can power it off by pointing down. You can charge it up by pointing it up.
Change the color by doing a circle or something.
Yeah, trigger a nice kind of swipe animation when you when it senses a certain threshold. Yeah. So it makes a lot of sense.
Yep, because for these shots, what we were doing was just faking it to do the shots that way, triggering animations as we do the motion.
Yeah, you're just kind of playing with the when the power on effect.
Yes, exactly. Yeah.
Yeah.
So you see this good animations. Yep, we'll get rid of the craft sticks, the glue
and tack, and
everything was all glued together, like sealed shut, glued. So I was trying to look for it to, sort of remember how I did the modeling for it, and I threw that thing away a while ago.
Yeah, it hasn't survived the kids playing with it.
Mm-hmm.
But yeah, still a build, but
it'll definitely be easier, I believe.
Yeah, creating the Y cables are always interesting.
Oh my god, I don't have to solder those anymore.
I don't think so. Yeah.
I don't have to do any Y cables. They can just share the connections on the terminal now.
Yeah, they can. Yeah, it just makes it vastly
so much
better, easier, and more advanced. So that's the Halo Energy Sword. It was suggested by Lamar, Lady Ada.
I saw some feedback in the guide for it too. I'm going through the feedback.
Yeah, folks are still building it. So
I think it was even was it last time?
A couple of weeks ago. Yeah,
it was a build for it.
Yeah. Yep. People still building it.
It's a cool TV show wasn't as good.
Maybe not as good, but it's still a great franchise.
Everybody still remembers the Energy Sword, even though I saw not one shot of it in the new game trailer. So hopefully they bring it back somehow.
Yeah.
So that's what I'm working on for that, and then another one that's still just like hooking stuff up. The Dune Spike. Somebody made one on printables and pitched that. PT loves Doom, so making one of those Doom spikes would be cool. Lamar suggested the transducer. So it's one of those speakers where it becomes the object that you place it on becomes the speaker. So there'll be a spike that just goes on a desk and will do like the sound for it. Kind of hear like a thump.
Mm-hmm. Yep. I wonder what the official name is. It's like a sand thumper, sandworm thumper. It attracts sandworms. That's what it does. Yeah. And I haven't seen Dune 2 yet because I'm waiting for it to come out on streaming.
Yeah, same here.
And maybe it'll line up nicely with the release of the stream. And
that's good. I thought it was already out. I was like, oh man, this is already old, but no, it'll be fresh again.
Yeah.
So we try to line things up with the releases of things that are relevant.
Yeah. Sometimes they're just random, but this time, kind of makes sense. Cool. That's what we're prototyping.
And what else? Time-lapse rig.
Yeah. Nothing yet, but we're still trying to figure out what. Do you hear something? What's wrong?
Yeah, it's like bass or something going on.
The sand thump. The worms are coming. That's what's going on. All right. If you want to pick up any of the parts that we showed, 10% off your order with a memory gun. All right. Good for the next 24 hours. All right, Pedro's got a time lapse. This was a challenge to print. Can we talk about how difficult it is to do a time lapse with this many pieces?
Tolerances. So I printed it out a couple times. First time, it completely fused together. Second time, like none of the parts were attached.
How did you fix that? Did you change
just the horizontal compensation?
Okay. So that's a feature in Cura Slicer that allows you to expand or contract the geometry of a part.
The walls. Yeah, the
walls. So you did need to do what? A negative or a positive?
Negative 0.1.
Negative 0.1.
Negative 0.15. That was too much. So what it does is makes the walls around there smaller. It like shrinks them to compensate for when like parts are too close together, so they don't fuse. So it sort of shrinks them so they're not touching. Just got to get the right number in or the values in. But yeah, super cool Fidget triangle. A lot of people have been using this sort of setup with like, I think I saw a face one where all the parts slide across. And it's a really nice little fidget. So what it is this little, I don't know what the object is, the name of it's like a little slider that goes across this rail, has a little end stop. So it'll not go beyond that and stay in place. And yeah, it's just a nice little way to utilize or to show off that geometry of having sliding like geometries.
Yeah. Printables user Martin posted this up as a free download. flexible toy gadget composed from sliding triangles, print to place. Nice little GIF here. But yeah, it's a triangle with subdivisions of triangles, and they all slide. Printed on a Bamboo Labs, which you know what? I guess that's why the tolerances didn't fit out. Every printer is going to have kind of a slightly different tolerances, and with this many print to place features, you're going to look at something.
I wonder how long it took him to print.
I don't know, but we know it was
probably a quarter of the time it took the cruelty.
A couple things here. No supports, 5 through 15% infill, layer height of 0.2. It was printed on a Bamboo Labs P1P, gold silk PLA.
Oh, yeah, it is about half the time. I think ours took like 12 hours.
Yeah, 5 hours. Yep. So that is that. I've been seeing a couple of other people print something similar. So this seems to be like an interesting mechanism, print in place design that can be applied to different geometries and shapes. So
yeah, I wonder if there's like a generator that takes this stuff and just applies it to whatever model.
Maybe. So here it is printing, and unfortunately, one of the pieces here pops off.
Oh, yeah. I even had a brim on this.
Oh, that would have been.
No, I did.
Hard to. Well, it would have been difficult to remove, right?
Because no, it's just one, and then I go in there with the pliers and remove it.
Oh, okay. Look at that Murray effect, huh?
I just saw it. Yeah.
Yeah, that's cool. I've seen this applied to like a really organic, like a skull, a head. Yeah. Have you seen that one going around?
Yeah, the base was the first one.
I think STL Effects does it. So this is just like a cool free one that we found, and shout out to Martin for releasing it. So it's more of like a torture test. Yeah. So here, yeah, you can download it. We have a link to it. I'll drop it in the Discord.
It's one of those cool things to show off what a 3D printer can do. That's really cool.
Yes.
Kids were immediately amazed by it.
Oh, really? Because yeah, it is a cool kind of.
I had
one of those 90s toys where it's like a bunch of metal pins and you would put your face or your hand through it.
Yeah,
it's kind of like that. It's got that similar.
This one's still sticking a little bit. I gotta go in there with the spudger and like sort of run it through all the edges to loosen it up. I see there.
Yeah,
comes off the plate. Still a little stuck, but you can loosen it up.
Fun. And I forgot to mention the reason why the print takes long. We'll have to do this every week, but just so folks know, the way to capture this time lapse is the printer head moves out of the way. Otherwise, you wouldn't be able to see the part.
Yeah.
And when it moves out of the way, it has to park the 3D printer head to a location that's away from the camera, but it's also going to a magnetic switch, which then triggers the camera to take a photo, and the photo itself has a delay. It's just the DSLR camera needs that delay.
Yeah, I know. It's the way that
it combined just increases the print time by, I guess, double the time. Yeah. And when it moves, unfortunately, the part gets some string sometimes, or in this case, it'll knock. Some oozing will happen from the nozzle, which will strike the printer head or the part, and that's what happened here. You can clearly see. You can't clearly see. That's why people are asking. At least one person asked, like, "Well, what happened to the part?"
Yeah,
it got knocked off while it was parking and trying to take a photo. And you can't just, these printers, these Creality printers, they move the bed, and if you're doing a bamboo and all you know is a bamboo printer. You don't know the bed doesn't move. It's only moving on the Z. It's not moving on the X and Y. So that's just kind of the insider shop talk of why
we're gonna do a whole guide on it.
Yeah, it's about time we do a guide on it.
Hopefully with some cooler features, like having a light trigger as well. So that would drastically cut down the amount of time the head needs to chill out.
The head needs to chill out. Yes, it does.
Yeah. And the lighting too. The whole reason why it's a little bit longer too is because I'm taking a long exposure photo. So it needs that stillness for that amount of time to get something that's correctly lit. It'd be nice if I didn't have to have the lights turned on all night long.
Yeah.
For this.
Yep.
So hopefully that'll fix it.
Yeah, I think so. Okay, so that's the time lapse.
That is this week's community make.
Yep.
We got a couple others, I believe.
We have one more community make. Let me load it here. Our community make comes to you by Jess Mary. Posted up their remix of the Heat Press Idler. They updated the idler with a more standard Z25, 625Z ball bearing, which is a little bit slightly bigger ball bearing, but it's completely modular. So this piece just adapts the top idler part so that it can use a more standard ball bearing.
I thought 680 was more standard, no?
Maybe. Let me see here. Ball bearing. We sell these ball bearings. I should have used. Yeah, your 608.
Yeah, 608, not 680.
See what I'm saying? Everyone has their own ball bearing, so you know.
That's why I released the files.
That's why I released the files, and there's plenty of remixes. So shout out to Jess for posting it up. Didn't want to order another size ball bearing, so I remixed it to fit the 625 because they had it in hand, and that's kind of the whole thing about this. Yep. So that's the community make. Shout out to them for posting it up, letting other people know. I really like community makes. We've been getting a few support emails on the lightsaber, and I finally added. Let me type in the lightsaber, just as a tangent here, but that's kind of nice. Under the CAD files on the lightsaber, I'm getting some reports that people are saying that the blade emitter isn't quite fitting, and luckily on printables, there's a whole slew of remixes of the blade emitter to fit various different types of 3D printers. So if you want it tighter or looser, check out the remixes on the lightsaber. And that is why we release the step file, so folks can remix the parts. You're always going to have a little bit of a different tolerances. Mm-hmm. And I felt it's time to add that to the Learn Guide so folks can check it out and not have to click the add support feedback button. We couldn't do this when we released it because it wasn't out there in the wild. So it's kind of my first thing to like highlighting it in a Learn Guide itself, saying, hey, if you have a problem with the parts, why don't you just look at the remixes?
Yeah.
So shout outs to Prusa printables.
Yeah, and Thingiverse too. Didn't fit either, but all I did was the horizontal expansion.
Right.
That's all I did, and it fit.
Yeah. Well, if I had that, I guess maybe write that too. We got a question from YouTube. Connor McCarter is asking, do either of you make a video on your time-lapse process?
Yes.
Not yet, but we'll work on that with this kind of upgrade that we're doing. So we'll cover that whole process, and we'll have a build tutorial on how to do it. So that's in the works. But yeah, it is time that we upgrade our setup and document our setup. So that'd be nice. In the works. All right, before I forget, we have 1 minute left. We have some new CAD parts that were added. Oh boy. Let me confirm this real quick. All right, I'm on GitHub now. Okay. New CAD parts were added this week to our GitHub CAD parts repo. What did we add? We added in the commits. We added a Stemma QT EMC 2101. That's a fan motor control driver. So we added that breakout. The INA 228 Stemma QT breakout. We added that. That was a part request. Thank you for adding that. We recently did a project with Liz that uses the USB host Feather wing. We added a 3D model of that. And that's this week. We added those 3 parts. Still going through the part requests. Those are the 3 that were added this week and last week, or I guess last week. We added the proto cowbell proto doubler and the single proto PCB to it. So check those out. Those are available to download in various CAD formats.
Nice.
And we'll work through the CAD parts as we have time.
Yay.
All right, that is pretty much the show. Again, don't forget coupon code Memory Gun will get you 10% off your order. Thank you for supporting the show. Support your maker habit. Get some parts. Lots of things are in stock. It's a good time right now. And we're working on stuff. I think next week we will be working on projects still. I think it's safe to say. We'll have a project and learn guide out in the next 2 weeks as we kind of ramp up on prototypes.
Yeah. See how fast I can get this printed out.
I would say just, yeah.
2
Do it at
weeks.
your pace. Yeah.
2 weeks.
Yeah, 2 weeks. 2 weeks. All right.
Now then I filament.
Right, you're gonna run out of filament. Tonight we invite you to come on Show and Tell. It starts at 7:30 p.m. Eastern time. I think it's going to be hosted by Mr. and Mrs. Lady Ada. I was out last week, so I'm not sure who's hosting it this week, but whoever is hosting will be a good time. So come on the Ada for Discord server 10 minutes before the show goes live. You get invited. Click on the link and get your mic and camera situated before we go live. Excited to see some stuff. And then Ask Engineer at 8 p.m. Eastern time. Full hour. Well, not full hour. I can't say that anymore, huh? A show, a live stream with Mr. and Mrs. Lady Ada. New products, INMPI, and more. It starts at 8 p.m. tonight, and another coupon code in case you missed this one. Tomorrow is Thursday, Jump Parks Workshop, live stream at 4 p.m. Eastern time. Come and hang out with John as he builds some fun stuff. On Fridays is a deep dive with either Tim, Foamy Guy, or Scott, who's the lead CircuitPython core developer. Come in at 2 p.m. Pacific or 5 p.m. Eastern on a Friday, every Friday, for a live stream deep dive. And then we don't do a Saturday show. We do a show on Sunday with Lady Ada. She does a live stream every Sunday from the desk of Lady Ada. What's she working on? Top secret stuff. And the Great Search with DigiKey segments. Mondays are CircuitPython week community meetings. They happen at 1 p.m. Tuesdays is JP's product pick of the week. We can get up to 50% off select items from JP. And then right back over to Wednesday, we have back-to-back shows with Show and Tell, Ask Engineer, and our show in the morning, 3D Hangouts. We're creeping up to episode 450, I guess, in the next months. Thanks, everybody, so much for watching. We'll be back next week. But until then, remember to make
a great day. See you next week.
Folks. See you tonight. Wee.